Hey, student, how are you? Welcome to our session on solving right triangles. We're going to do 4 problems. Number 1, I see that they gave us this angle, and all the angles we're going to work with today are going to be in degrees, so make sure your calculator is in degrees. And let's solve for x. I see that x is the opposite side of the given angle, opposite side. They also gave us the adjacent side of this angle. Opposite over adjacent, we think tangent. Tangent of an angle is equal to the opposite side over the adjacent side. And let's fill in this formula. The angle, 46.4 degrees. Opposite side is x. And the adjacent side is 20. We'll multiply by 20, and then we'll put this in the calculator. 20 times tangent of 46.4 degrees. And we get 21. Now we can solve for the hypotenuse, y. Solve for y. We've got 2 out of the 3 sides of our right triangle, so we can use our Pythagorean theorem. Let's let A be 20, and B will be 21, and C is the hypotenuse, y. And we'll fill in our formula. 20 squared plus 21 squared is equal to y squared. 20 squared is 400. 21 squared is 441. And we'll add those together. We get 841 is equal to y squared. And then we'll take the square root of 841. Square root of 841 is 29. 29. And now let's solve for z, the angle. Angles in triangles add up to 180 degrees. We've got the 90-degree angle plus 46.4 degree angle plus z, and these 3 angles add up to 180. We'll subtract 90, and then we'll subtract 46.4. 90 minus 46.4, and we're left with 43.6 for z. Number 2. Number 2, let's solve for x. Solve for x. Oh, they gave us 2 out of the 3 sides of our right triangle. We've got side A, side B, and then the hypotenuse has to be C. We'll use the Pythagorean theorem to solve for the missing side. We get 8 squared plus x squared is equal to 12.5 all squared. 8 squared is 64, and 12.5 squared is 156.25. And we'll subtract 64. Subtract 64. And we're left with x squared is equal to 92.25. And then we'll take the square root of 92.25. And the square root of 92.25, we get about 9.6. 9.6 for our missing side. Now let's solve for y. Y is an angle. To solve for an angle, we need inverse trig. Inverse trig. Let's see. To solve for the angle y, we have 8 is the adjacent side, and the hypotenuse is 12.5. Adjacent over hypotenuse, we need cosine. And to solve for an angle, we'll use inverse cosine. Adjacent over hypotenuse equals angle. And we'll fill in our inverse cosine formula. Inverse cosine of 8 over 12.5 is equal to the angle. And we'll put that in the calculator. Inverse cosine, 8 over 12.5. And we get 50.2 degrees for the angle, for y. And now let's solve for z. Angles and triangles add up to 180 degrees. We've got the 90-degree angle plus angle y, 50.2 degrees, plus z. And we'll subtract 90 and then subtract 50.2. 90 minus 50.2, we get 39.8 degrees for z. Number 3. Number 3. They have us solving for x, the angle, first. Solve for x. And angles and triangles add up to 180 degrees. We've got the 90-degree angle plus 30 degrees plus x. And we'll subtract 90 and then subtract 30. 90 minus 30 and we get 60. This is a 30, 60, 90 special right triangle. You could solve it that way. However, let's say you didn't notice it was a special 30, 60, 90 right triangle, and we'll solve for y, the hypotenuse, using trigonometry. I'm going to use the angle 30 degrees to solve for y. They gave us the opposite side of 30 degrees, and I'm solving for the hypotenuse. Opposite over hypotenuse, we're going to use sine. Sine of an angle is equal to the opposite side over the hypotenuse. And we'll fill in our formula. Sine of our angle, 30 degrees, is equal to 7 over y. We'll multiply by y to bring it over to the other side of the equal sign, and then we'll divide 7 divided by sine of 30. And we'll put that in the calculator, 7 divided by sine of 30, and we get y is equal to 14. And now we've got 2 out of the 3 sides. We can use the Pythagorean theorem to solve for z. A squared plus b squared is equal to c squared. A will be z, so we'll get z squared plus b is 7, 7 squared, is equal to 14 squared. Z squared plus 7 squared is 49. 14 squared is 196. And we'll subtract 49 minus 49. And we get z squared is equal to 147. And then we'll take the square root. Now, I would like to leave this in radical form. Z is equal to the square root of 147. I want to simplify the square root of 147. We can rewrite the square root of 147 as the square root of 3 times 49. And now 49 is a perfect square. We can take the square root of 49 out from underneath the square root, and we get 7 square root of 3. So our last side, z, is 7 square root of 3. And number 4, last one. Number 4, you may also notice that this is a special right triangle. But let's say you didn't notice, and we'll solve for x. We've got the hypotenuse, c, and we've got the other leg, 5. We can use our Pythagorean theorem to solve. And we get x squared plus 5 squared is equal to 5 square root of 2 all squared. And we get 5 squared is 25, and then square root of 2 squared is 2. 25 times 2 is 50. And we'll subtract 25 and take the square root of 25. We get 5. We've got two equal sides. When you have two equal sides, you also have two equal angles. So to solve for y and z, y is equal to z. Equal sides, equal angles. We've got an isosceles right triangle. Angles in triangles add up to 180 degrees. We've got the 90-degree angle plus y plus z. And since y is equal to z, I'm going to substitute y in for z. And now we have combined like terms, 2y. We'll subtract 90 and divide by 2. So y is 45 degrees and z is also 45 degrees. We've got a special 45, 45, 90 right triangle. And that concludes our session on solving right triangles. Thanks so much for joining our session, and I'll see you next time.